Hello, everyone, and welcome to Flat Earth Science Series, Episode 6 Missing an Independent Variable, or you can call it Missing with an Independent Variable. That's what we're going to do. My previous episode was about the Sleeping Warrior challenging the buoyancy and gravity with his theory of relative density. But I'd like to say to him and everyone again, this is science, what I'm showing you right here on the screen. The buoyant force is related to the density of the liquid, the volume displaced of the liquid, and the gravity. And in the previous episode also, I showed this as a proof for the existence of the downward acceleration of 9.8. And I prefer this example better than calculating how fast objects are going to fall because they meet the resistance of the air when they hit their terminal velocity. So this is more accurate and you can do it anywhere. If you hop in a merry-go-round or in a car and you're turning and you know the radius of the turn and you know the speed of the vehicle, so you can calculate the centrifugal force, or you can call it the centrifugal acceleration. And this acceleration is horizontal, and as you see in the example, it's 5.66. And presuming there's a vertical acceleration of 9.8, then the component or the summation of these acceleration will be 11.3 or 1.15 g. So this is the calculations, and when you go to reality, you find that these calculations matches the reality. So yes, there's a 9.89 meters per second square downward acceleration, and I'm not the only one who made this video about this week. Whereas Wally made one, and even Bob from Globebusters made the same video assuring the same point that there is downward acceleration of 9.8 meter per second. He didn't go into the reasons why, but he recognized there is a downward acceleration. So in my previous video, I showed some videos from Zero G Plane and Action Lab showing how air bubbles are suspended when you release a bottle. Bob showed the same thing, and Where's Wally showed the same thing. So in our three videos, the manipulation of gravity was just to eliminate it by dropping something or go in a free fall or in a parabolic path. In this video, I'm going to go to another thing, how to manipulate gravity with more calculated methods. But first of all, let's go back to the theory of Sleeping Warrior, or most of Flat Earthers for now. And in this case, the upward force between the egg and the water is a result of multiplying the heavier or the denser fluid minus then the density of the egg. Somehow, this is supposed to produce an upward force. While in the mainstream science, the upward force is a result of subtracting the mass multiplied g from the density of the liquid multiplied by the volume displaced multiplied by g. So this will be the setting of our experiment. You get a ping pong ball and you suspend it like that by pulley in a beaker, and you put some weight to measure the weight, or in this case, it will measure a force, which is the force of buoyancy. But not only buoyancy, get back here and look. The upward force equals the force of buoyancy minus the force of weight of that object. According to Flat Earth hypothesis, except for Bob, of course, the force will be somehow related to Pf minus Po, and the science hypothesis will be as I displayed, and it changes according to acceleration. In the first hypothesis, there's no change when acceleration changes. So what we're gonna do is just take this apparatus and drive with it in a turn, or maybe put it on a merry-go-round. Anything that goes in a turn with a constant speed, a constant known speed, and a known radius. And from that speed and radius, we can calculate the horizontal centrifugal force. And combining this with the 9.8, you can get the total load factor. So what we're doing here is we're manipulating an independent variable, that is the g. We're increasing it, in fact. So the hypothesis says that when you increase the g, the weight will increase and the buoyancy will increase in a certain way according to the calculations you see on the screen. Now all you need to do the math according to the angle that you are going to measure, or the calculated centrifugal force. You see your calculations. If it matches what you're reading, then the hypothesis is right. I think that's how simple it is. It cannot be more simple than this. Manipulate the independent variable that you think it will affect the experiment in a certain way. And when this is done, then you're on the right path. Thank you for watching.